We talked about expanding. Of course, we've got to go back the other way, putting things into factors. Okay, thought process when you're factorising. Always, the first time you do it, look for a common factor. It's amazing how often people forget to do it and make things harder for themselves. It's the simplest factor of them all. Always pull it out first. Then, the number of terms the expression has gives you a clue on how to solve the problem. If you only have 2 terms, there's not a heck of a lot there could be. Maybe it's the difference of 2 squares. You're looking for that. Is it the sum and difference of 2 cubes? That's another very common one that we see. If there's 3 terms, then is it a quadratic? Because we've got techniques for factorising quadratics. That's what I'm looking for. If it has 4 terms, it starts getting tough. Can I group it in pairs and make it an easier thing to do? That's what I'm doing with 4 terms. So they're basic ideas of the thought process when we're factorising. So common factor, let's do a very simple example. Remember, factorising is simply this: dividing by a common factor. One of the biggest things people have when they factorise, they go, oh, hang on, what should be left in the parentheses? Well, you just divide by whatever you're taken out, and that's what you're left with. Very easy, isn't it? Common factor, I wonder what it's got. There's an x in both of them, we pull it out. So what's ax divided by x? It's a. What's bx divided by x? It's b. X outside a plus b. That's what I'm saying. So 5x squared minus 10x, why do I put this one in here? Just to remind you, all of the common factors, very common to just pull one out and forget the other. In this one, of course, there's a 5 as well as x. 5x, x minus 2. Common factor, 4 terms. So you look at this one, you go, oh, u-but. There's x and x. Oh, damn, there's no x's in the other one. Oh, m, oh, look, m. Oh, there's only m in 2 of them. N, oh, damn, there's no common factor in all of them. So you go, I've got 4 terms. Maybe I can break it down to pairs and see what happens. So the first one, I can pull an x out of those. But the trick, of course, with something like this is to pull out a negative factor in the other one so that what's left in the parentheses is the same. Because now you've got an expression that you're factorising with 2 terms and they have a common factor of n minus n. Pull it out, what am I left with? Well, if I divide x outside of m minus n by m minus n, I get x. Divide the other one, I get minus y. There it is. Difference of 2 squares. Remember, a squared minus b squared. More correct to say a minus b goes first. A minus b, then a plus b. It doesn't matter. It's not wrong to have it the other way around, but technically it's more correct to have the a minus b first. 16x squared minus 1. There it is. Brilliant. 16x squared, that's 4x all squared. 1 is 1 squared. 3y squared minus 75. Oh no, surely they don't want us to have surds. Square root of 3y? Square root of 75? No. Always look for the common factor first. There is a common factor of 3. Y squared minus 25 then becomes easier. Okay, whoa. 4 terms. 4 terms. Can we group in pairs? There's nothing to say when you group in pairs that both of those are going to be common factor ones. It could be different techniques. Now the first one here, sure, 5 common factor. The second one though, difference of 2 squares. X minus y, x plus y. I've now got 2 things. They have a common factor of x minus y. We have our answer. Monic quadratic. Think of the final answer. The final answer is going to be a binomial product. If you were to expand the general one out, that's what you get. And this is why we ask ourselves what multiplies together to give the last number, what adds together to give the middle number. That's the basic idea behind solving a quadratic. So what multiplies to give 18 adds together to give 9. I'm looking for either 2 positive numbers or 2 negative numbers because I've got a positive answer. Well, hang on, if they're going to add to give a positive, it's got to be 2 positive numbers. So multiply 18, 9, 6 and 3 looks good. There it is. T squared minus 4t plus 3. But in this case, I know one number's going to be... we're going to have 2 negatives, aren't we? Multiplies together to give a positive, adds together to give a negative. Got to be negative numbers we're talking about. So we've got negative 3, negative 1. Again, don't worry about the x and the y, just look at the numbers. That's what's important here. Multiplies together to give 4, adds together to give negative 5. That would be 4 and 1, but when we write it down, it's 4y and 1y. Put the pronumeral back in. Splitting the middle. Love it. You know when you have these ones, some people, the cross method. Anyone use the cross method, by the way? Oh, good. Everyone gets shown this thing. You've seen the cross method. You know what I'm talking about with the cross? Such an inefficient way of solving, factorising things. Cross method. Why do I love splitting the middle? Because it's still the same idea. You're still going through that thought process of what multiplies together to give a number, what adds together to give a number. The only thing we have to be careful with is we multiply the constant by the coefficient of x squared when we're asking ourselves. So we don't say what multiplies together to give -7, we say what multiplies together to give -21. But other than that, it's the same thought process. Multiplies together to give a negative number. So one's positive, one's negative. The bigger number must be positive because we've ended up with a positive number. So multiply 21, got to have a difference of 4. That's 7 and 3, isn't it? So we physically split the middle. That's why it's called split in the middle. We split the middle. It becomes a grouping in pairs question. We pull out the common factor, we group the pairs, we've got the answer. Okay, multiplies together, -24 adds to give -24. Again, one's positive, one's negative, adds together to give a negative number, so the bigger number's got to be the negative one. Multiplies 24, difference of 5, got to be 8 and 3. Split the middle, factorise, pull it back together. X minus 4, 2x plus 3. Okay. We've got an asterisk on that 9 there as well.